Welcome to Server Logic Simplified.
Imagine you and a colleague are both working on a shared spreadsheet at the same time. If one of you makes a change but hasn't saved it yet, and the other person looks at that unsaved change and makes a decision based on it, what happens if the first person then decides to undo their change? That could lead to some real confusion and incorrect work. In a database, this exact scenario is called a dirty read, and it is a significant problem. Database isolation levels prevent dirty reads by creating strict rules about when one transaction can see the uncommitted changes made by another. This ensures data integrity and consistency, making sure your applications always work with reliable information. The core mechanism at play here is transaction isolation. A dirty read occurs when a transaction reads data that has been written by another transaction but has not yet been committed. If the writing transaction later rolls back its changes, the data read by the first transaction becomes invalid or dirty. This can lead to incorrect calculations, inconsistent reports, or even corrupted data if subsequent operations are based on that faulty information. To combat this, database management systems employ various isolation levels. The read uncommitted isolation level, for example, explicitly permits dirty reads because it prioritizes performance over strict consistency. However, more robust levels like read committed, repeatable read, and serializable are designed specifically to eliminate this risk. To actively prevent dirty reads, the read committed isolation level is the minimum standard you should generally use. Under read committed, a transaction can only see data that has been committed by other transactions. Any changes made by another transaction that are still in progress and not yet committed are simply not visible. This is typically achieved through either locking mechanisms, where a transaction holds a lock on data it is modifying until it commits or rolls back, or by using a technique called multi-version concurrency control, also known as MVCC. With MVCC, each transaction operates on its own snapshot of the database, ensuring it only ever reads committed versions of data. The repeatable read and serializable isolation levels also inherently prevent dirty reads, as they offer even stronger guarantees than read committed. Multi-version concurrency control is a fascinating approach to managing concurrent access without relying solely on locks. Instead of blocking readers when a writer is active, MVCC creates different versions of data. When a transaction starts, it gets a consistent snapshot of the database. This means that a reading transaction will only ever see data that was committed at the time its snapshot was taken, completely avoiding any dirty reads from ongoing, uncommitted transactions. It is a powerful way to improve concurrency because readers do not block writers, and writers do not block readers. This insider technique allows for high throughput while maintaining strong data integrity. Understanding and selecting the appropriate database isolation level is paramount for developing reliable and high-performance applications. By choosing an isolation level like read committed or higher, you actively shield your database from the perils of dirty reads, ensuring that every piece of information your application processes is consistent and valid. This careful management of concurrent transactions builds a foundation of trust in your data, leading to more robust systems and confident decision-making.
If this helps you code smarter, like, subscribe, and stay tuned for more.